Now we'll find the distance between two parallel lines. So firstly, let's take the coordinate axis and two parallel lines. Let the equation of the first line be y equals mx plus c1, and for the second line be y equals mx plus c2. Now, as you know, as the lines are parallel, their slopes are equal. Now, what we have to do is we have to find the distance between these two lines. So let's do a thing. From the second line, let's drop a perpendicular on the first line, which intersects the x-axis. Now, as you know, as it's the perpendicular, it's the distance. Let's take this as the distance d. Now, let's take this point as P. Now, as this is the x-intercept, coordinates will be these are the coordinates. Now, as you know, you have to find this distance d. Now, this is nothing but what we learned previously, that is the distance between a line and a point. So we're going to apply the same formula over here. Now, let me just write the equation of the first line was equal to mx plus c1, and the second y equals mx plus c2. Now, as you know, the formula is d equals mod of a x1 plus b y1 plus, now as you are finding the distance between this line, whose constant is c2. So you write c2 upon square root of a square plus b square. Now just note this, as these are in y is equals to mx plus c wala form, we'll write this as this can also be written as minus mx plus y minus c2 equals 0. Now you can, so this is the a, here there is the 1, there is 1 which is the coefficient of y, that is b, and this minus c2 is nothing but the c2, the c over here. Now let's go ahead and just substitute these values. So after substitution, you get mod of minus m into minus c1 by m plus minus c2 divided by, now place of a you get minus m square the root, and place of b you get 1, as that was the coefficient of y. Now after you simplify this, m and m gets cancelled. After you simplify this, you get it in this form, d equals c1 minus c2 upon root of 1 plus m square. So this is the distance between the two parallel lines.